Okay, so section 3.3 is all about proving that lines are parallel. So in the last section, we talked about properties, if they were parallel, what you could use, and now we're going to take those same properties, and if those are true, we're going to say, if they're true, then we're going to say, okay, then they are parallel lines. Okay, so for example, if you have a transversal, and remember, the line, this is a transversal, it's a line that cuts through two other lines, and the corresponding angles in that transversal are congruent, then they're parallel. So if the corresponding angles are congruent, it's parallel. Sounds like the corresponding angle postulate, but you say converse of the corresponding angle postulate. The next one's the theorems. So the converse of the alternate interior angles theorem. So if you have a transversal that cuts through two lines and their alternate interior angles are congruent, then line L is parallel to line M. The converse of the same side interior angles theorem. So if they're on the same side and they're in the interior section of your transversal, and they are supplementary, meaning they add to be 180, then those two lines, L and M, are parallel. And the last one, if you have alternate exterior angles that are congruent, then those lines are parallel. So, which lines are parallel if 6 is congruent to 7? So what can you see about 6 and 7? So looks like to me that would be talking about this section right here. That's all you can see. You can't do anything with that line A. So if they're corresponding angles, they're corresponding angles and they are congruent, that would mean that line L is parallel to line M. Why? Because of the converse of the corresponding angles postulate. Okay, next one. Which lines are parallel if angle 1 is congruent to angle 2? So angle 1 is congruent to angle 2. That's something very similar. So what is the transversal with those two lines? Well, the transversal is M. So we're talking about this section right here. Oops, you can't see that. 1 and 2. Okay, so they are also corresponding. So that would mean that line A is parallel to line B. And again, it's the same reason as the last one, as the converse of the corresponding angles postulate. Okay, and at the bottom of this page, what is the value for X for which A and B are parallel? So if A and B are parallel, then what type of angles are those? Well, they're going to be same side interior. So that means that they would be equal to 180. So we're going to have 2x plus 9, the one angle, and then we're going to add the other angle to that. In total, they should equal 180. Now let's go ahead and solve. Oops. So we're going to add the 9 and the 111. So that would give me 2x plus 120 equals 180. Subtract 120 from both sides. 2x equals 60. Divide by 2. So x equals 30. And that's our answer. Okay, so the next page of notes. What is the value for W for which C is parallel to D? So if C and D were parallel, they would be equivalent because they're corresponding angles, right? So if they're equivalent, they're equal, you just solve it like that. So you do 55 equals 3W minus 2. And that's only because they're corresponding, and corresponding angles are congruent if the lines are parallel, which it told us to assume that. So let's solve it. We're going to add 2 to both sides. 57 equals 3w. Divide both sides by 3. So w equals 19. That's it. Okay, so given that angle 1 is congruent to angle 2, so angle 1 is congruent to angle 2, you can use the converse of an alternate exterior angles theorem to prove that lines R and S are parallel. What is another way you can explain why R and S are parallel? Okay, well, it only gives us one other angle to talk about, and that's 3, so we know we're going to be needing to talk about that. So let's look. Besides, well, how else could you see this? If 1 is congruent to 2, what do you notice about 2 and 3? What type of angles are those? Well, they're vertical because, so let's say these are vertical. That means they're congruent. 3 and 2 are congruent. So then 1 and 3 must be congruent too, because, or 1 and 3 are congruent too because they are corresponding. So let's just write this out. It doesn't ask us to write a proof. We're just going to explain. Yes, it is possible to have another way to explain why R is parallel to S. And then we would just kind of write it out. Angles 2 and 3 are vertical. So vertical angles theorem. And angle 1 and 2 are the alternate exterior, like they said. And so then by the transitive, 1 and 3 must be congruent. That's the transitive. So I guess I did make you do a proof, but it wasn't a formal one. Just kind of explaining. Transitive property of congruence. I should finish that. Okay, last part. This is a proof, a real one, not a fake pretend one. So let's set it up. We've got our statements and we've got our reasons. So first, of course, start with your given. Angle 1 is congruent to angle 7. Given. So there was a theorem, remember, that talks about those two angles. And what are those angles? Well, they're alternate exterior angles. So this is going to be a real short proof. That's good. So the second one is, we're done. Because if 1 and 7 are congruent, then the converse of the alternate exterior angles theorem tells us that L must be parallel to M. And we are done. So we did have to do a formal proof in this lesson, but it was a quick one, so it's not that big of a deal. Don't yell at me. All right, well, thanks for watching. I hope you have a great day.